Welcome back, everyone. We are now on to our next mini unit, logarithms. This is lesson 4, Intro to Logarithms. So today you will be able to evaluate and simplify, well, logarithms. So the first thing we're going to do is we're going to start with solving some equations. Let's solve for x. So our first one, we have 2x is equal to 100. So to solve, all we have to do is just divide by 2. And we get x is equal to 50. So that one, we're a-okay. We're good to go. Sorry, fuzziness real quick. All right, our next one, we have x squared is equal to 100. Remember to undo a square root. Or a square, we square root it. So here we have x equals 10. Again, something that we can do. But now here we have 2 to the x is equal to 100. So now our exponent is the variable we're solving for. We can't divide by 2 because x is in the exponent spot. We can't square root it because we don't have, an x root. So we don't have anything in our toolbox yet to solve when our variable is in the exponent spot. And that is what we're going to be talking about today, how we go about doing that. So the operation 2 to the x is an exponential equation. To solve this equation, we need to ask ourselves, to what power would you raise the base 2 to get 10? Well, if we think about it, remember exponents is just multiplying. So, okay, if it was, 2 squared, that would be 4, so that's not it. 2 times 2 times 2 would be 8. That's not 100. And so we would just keep going, and we can just keep going and guessing and checking, or we can use what they call logarithms to help us undo an exponent. So the inverse of an exponent is called a logarithm. So to undo an exponent, we will use a log, and that's how I'm going to abbreviate logarithm going forward, is just log. So the exponential form of something shows a base. So exponential form, a base raised to an exponent equal to a result. So this is exponential form. It's something we are quite familiar with. We just took a test on our exponent unit. And now we have logarithmic form. So this shows that the log of the result of the given base equals the exponent. So we have a log of the base, log base b of the result is equal to our exponent. So as you can see, each of these 3 pieces from exponential form translates to log form, and we put log attached to it. So the base of our exponent is the base of our log. The exponent is what the log is equal to, and then what the exponent is equal to is the what I call the of our log. So each thing in exponential form has a place in log form, and we can go between the two. And so that's the primary thing we're going to be doing today, is converting between exponential and logarithmic forms. So what is the logarithmic form of 3 to the 4th is equal to 81? So the first thing I do is I write log, and then my base. So the base of my exponent is 3. So we're going to write that smaller underneath. Log base 3 of. So that's my y here. And that's what my exponent is equal to. My exponent is equal to 81, so log base 3 of 81 is equal to, well, it's equal to the exponent. And our exponent is 4. And there we go. We converted from exponent form to logarithmic form. Let's do another one. What is the logarithmic form of 5 to the x is equal to 120? So again, we start with log. All right, our base is 5. And then my of is what the exponent is equal to, so 120. And we're equal to the exponent, which is x. So there we go. Now we're going to go the other way. Now we're going to go from logarithmic form to exponential. So what is the exponential form of log base 15 of 3,375 is equal to 3? All right, so my base, that's the little number on the log. So 15. My exponent is what the log is equal to, 3. And then it's equal to my, what I call the of 3,375. So what is the exponential form of log base 2 of x is equal to y? So base is the little number. So my base is 2. My of is what it's equal to, so y. And then equal to whatever we have left, which is x. So there we go, converting between exponential and logarithmic forms. All right, the next concept that is going to use this conversion is evaluating logarithms using mental math. These should either be whole numbers or fractions. You will not be getting weird decimals, and you will not be using calculators here. So using mental math, what is the value of each logarithmic expression? First, convert to exponent form. Then ask yourself, what power of base is result? So the first thing I recommend doing here is setting the log equal to a question mark. So that way we know, okay, how can I write this in exponent form? So log base 5 of 25 is equal to question mark. So exponent form. My base is 5. Exponent is question mark is equal to 125. So what does our exponent need to be for 5 to the power of it to equal 125? Well, 5 times 5 times 5 is 125. So our question mark is 3. Log base 2 of 32 is equal to question mark. So we have 2 to the power of question mark is equal to 32. So how many times do we have to multiply 2 by itself to get 32? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that is 1, 2, 3, 4, 5 2's. So question mark is equal to 5. And then finally, log base 4 of 1 is equal to question mark. So 4 to the question mark is equal to 1. Now, remember, this was a special rule we had in properties of exponents. Any base raised to a certain power is always going to be 1. Do you remember what that power is? It is 0. Any base raised to the power of 0 is equal to 1. All right, we're going to practice a little bit more of this mental math starting the next video and moving on from there.